Today we're going to talk about similarity between specifically triangles and how we can take some shortcuts to figure out what those similarities are. So we don't, the definition of similarity is similar is all the angles are congruent and all the sides are proportional. But in triangles, we don't need to know all of that information to conclude that the triangles are indeed similar. It's kind of like when we were proving triangles congruent, except for now we're proving them similar. So there's three ways. One is the angle-angle similarity. If two angles in one triangle match two angles in another, the triangles will be similar. Question about that? Okay. Second way is the side-angle-side similarity. So the side-angle-side similarity is not like the side-angle-side congruency. Side-angle-side similarity means that the two sides are proportional and the included angle is congruent. So here the angles would need to be congruent, and the red over the red, it should be proportional to the blue over the blue. So red over red equal blue over blue. And then finally we have the side-side-side similarity, which says if all the sides are proportional, if you have an extended proportion, then the triangle is similar. So two angles, they're similar. All three sides, they're similar. Or two sides proportional in an included angle, they're similar. Does that make sense? Yeah. This came off page 450 and 451 if you want to go back and look at these charts. All right, so what does this mean? So in this example right here, are the two triangles similar? The answer would be yes, because this angle is congruent to this angle. By vertical angles are congruent. And now we have two angles. So by side-side similarity, the two triangles are congruent.
Well, do you mean angle-angle?
Yeah, what did I say, side-side? My bad. I meant by angle similarity. The two triangles are similar. Here I can do some math. I can go through and figure the third angle over here. If this is 30 and this is 70, then this angle up here has to be 80. I don't have any two angles here that match two angles in here, so those would be not similar. Because they don't meet, I know all the angles of both triangles and they don't meet the angle-angle congruency. Any questions about that? All right, do these two real quick. All right, what about part A?
Yeah.
Why?
Because the two angles are congruent.
What's this angle right here?
51.
51. So when I know that's 51, I have angle-angle. What about here? What's this angle right here? So I don't have angle-side-angle similarity because these two angles were different. So not similar. It's pretty bad handwriting. All right. Are the triangles similar? If so, write the similarity statement. So to decide if the triangles are similar, since I have all the sides as information, I think I'm going to go through and I'm going to try for side-side-side similarity. So the biggest side is SU over the biggest side XW, and that would need to equal the middle side, which is UT, over WV, and the smallest side is ST over VX. So that is, the question I'm asking is 10 over 15 equal to 8 over 12 equal to 6 over 9. Is that true?
So when you're writing it, you write the small side, the largest side?
I did left to right. And so left to right was smallest to largest. So 10 over 15 reduces to what? 8 over 12 reduces to what? 6 over 9 reduces to 2/3. So those all check. That's all true. So are the triangles similar? Yes. If so, write a similarity statement. Well, it doesn't matter what order I organize my letters in the first triangle, but the corresponding parts have to match up. So going from S to T, that was the 6 side. To do that, I need to go from V to x. So VXW is going to be my similarity statement. Small, medium, large, small. Oh, I should have gone from X to V to W. Got to be careful about that. So smallest side, medium side, largest side, smallest side, medium side, largest side. Make sure that you get it proportional. Make sure you match up the corresponding parts. All right. In part B, it is very, very useful sometimes to draw an auxiliary drawing. Auxiliary drawings will always be your friend. So I've got a triangle stuck inside another triangle. I'm going to draw the triangle stuck inside, and I'm going to draw the big triangle. And I'm going to label the corresponding sides. So this was 8 and this was 12, but this was 8 plus 2, which was 10. And this is 12 plus 3, which is 15. So Kn is that whole thing, which is 15. Km is that whole thing, which is 10. And then since both of them share angle K, K is congruent to itself by the reflexive. So is 8 over 10 equal to 12 over 15? What does 8 over 10 reduce to? 4/5. What does 12 over 15 reduce to? 4/5. So those are equal. So therefore, yes, it was similar by side angle side similarity. And my congruency statement is going to be angle KLP. I said congruency, but it's similarity. Is similar to angle KMN. Everybody get that? All right, here's a couple for you to do. So yeah, here we only have two sides to compare. 6 over 8, 6 over 8, 9 over 12. So the 6 over 8 and the 9 over 12 are really the only two I care about. Those are equal. So it's similar. So it's similar by side, side, side similarity. And then the similarity statement would be triangle ABC similar to triangle FEG, because I want to go longer side and then the two congruent, longer side and then the two congruent. So that was A. What about B? No, why not?
Because one side is 1/2 and the other side is 2 over 1. So they're not proportional.
Did you draw the auxiliary drawing?
Yeah.
So it is. So it's ALW, which is 6 and 8 with a right angle. And then it's AEC with a 12 and 16 and a right angle. So it's 6 over 12 and 8 over 16. You have to be consistent when you're setting it up. So 6 over 12 is equal to 8 over 16. That checks. So it's side, angle, side similarity. My similarity statement would be triangle AWL similar to triangle AEC. That make sense? Any questions about that stuff? Because this is the easy stuff. All right, moving on. Proofs. You know you missed them. So for this proof, what am I going to start out doing? The given. So I think I'm just going to take a picture of it because I'm lazy. So here's the given statement. I know at some point that I'm going to need the proof statement. So that's going to be in here somewhere. I'll just set it down at the bottom for right now. All right, so reason number 1 is given. So what kind of triangles are these? Isosceles triangles. So what do you know about isosceles triangles? Their base angles are congruent, aren't they? So in this case, can't I say that angle H is congruent to angle L. What would that reason be again? Close. Isosceles triangle theorem. And if I'd started out with the angles and wanted to know the sides, that would be the converse of the isosceles triangle theorem. All right, so now I know that angle H is congruent to angle F, and I know that angle L is congruent to angle J. How does that relate H and L together?
Well, we haven't proved the triangles.
Okay, I'll do that. So how do we know? If this is equal to that, and that's equal to that, but these two are equal, how come these two are equal?
What's your question?
So I know that this is congruent to that, and I know that this is congruent to that, and that's congruent to that.
Why aren't the sides congruent? Is that what you're asking?
I'm just asking about how can I prove angle H and angle L are congruent, because I wrote that down, but that's not true. That's not true yet.
Yeah,
Angle H should be congruent to
angle
G, J, no, F, and angle J should be congruent to angle L.
And then you have to prove the triangles congruent.
Right. So couldn't I say that angle F is congruent to angle L by transitive? F to J, J to L, so F to L. And then now can I say angle H congruent to angle L by transitive again? So I just do the transitive property twice. So let me highlight that. So we had F, and we had, we had J here and J here. So this line connects the F and the L. And then we have F here and F here, and that connects the H and the L. If you just did that in one step and said transitive, that's not as rigorous, but I probably would accept it. And then step 5, now that we know that we have two angles congruent in one triangle, congruent to two different angles in the other triangle, it is angle, angle, similarity. See how proofs go? Y'all remember them?
I remember,
Well, there you go. All right, you do this proof. You can work with your partner. All right, so first thing I'm going to do is put the given down. So, do you remember anything about parallel lines?
Yeah.
What?
The opposite angles are congruent.
No, not opposite, close.
Corresponding.
Corresponding angles will be congruent when two parallel lines are cut by a transversal. What else?
Alternate.
Yeah, so angle A is congruent to angle P because alt, int, angles, congruent if lines parallel. Then, so that's that congruent to that. Then why would be maybe angle CBA be congruent to angle MBP?
Vertical angles congruent.
Vertical angles. Reflexive means the same angle, not just the same vertex. All right, and then once you know that you have two angles, then you can say your proof statement. So see, that wasn't hard. because once you know that those angles, then you have it proved by angle-angle similarity. Everybody okay with that?
Couldn't you say like C is also congruent?
You could also say C is congruent to M, and that would give you two angles. All right. One of the ways that you use similar triangles, and this actually gets used a lot, is by something called indirect measurement, where we can find lengths that we can find and set up a proportionary triangle system and then find the distance of what we can't actually physically measure. For example, I know how tall I am, and I can put a mirror on the ground in front of me, and I can decide how far away I am from the mirror, and I can decide how far away the mirror is from this thing that I'm trying to measure, which is the cliff, but I can't necessarily climb up a sheer cliff face to measure that distance. So in this example right here, we've got a triangle over here that's formed similar to this triangle. Now the reason that these two triangles are similar is because I stand vertically with the ground, and the cliff face stands vertically with the ground. And in physics, if you study physics, you'll notice that light always bounces off and forms congruent angles with the ground. So if I'm looking into a mirror, so what I would do is I would put the mirror on the ground, and then I would look into the mirror, and I would back up until I saw the top of the cliff face. And that's what would give me this situation. I mean, I want to know how tall that cliff is, but I can't climb it to measure it. I know you've got an app on your phone that measures the cliff face, but this is the way we had to do it old school.
I mean, do people actually come into these situations where they have a mirror and a cliff and they like actually want to measure?
Well, probably not this, but have you ever seen like the guys out on the roadway with the little tripods and the things they're looking for?
Yeah.
So the city has designed a system underground of connected pipes and stuff like that, and when you want to repave something or do some construction, you don't want to drill down that you bust a pipe. So we know where those are located, but we have to use something similar to this technique to find the exact location, so I can paint a big red X on the pavement saying, don't drill here or you'll blow the city up. So it's pretty useful. All right, so here's our situation. So what I would do is I would notice that these two triangles are similar. By the way, why are they similar? Seriously?
No, I'm joking. Because they're angles.
Angle-angle similarity. So the 5.5 height of the figure is corresponding to what side in the big triangle? X. And the 6 feet is corresponding with what side in the other triangle? I can't see it either. Let me go back to the bigger picture. 34. Can I solve that problem right there? Sure. By the magic power of what? Math. Cross multiplication, or means extreme if you want to get technical. So 5.5 times 34 is equal to 187. Divide that by 6, and x is equal to 31 and 1/6. No. Yeah, 31 and 1/6. I guess a better way to write that would be 31 times 6 would be 187 over 6 feet. But 31 and 1/6, that's the same thing. So that's how tall that cliff face is. 31 and 1/6 foot. Or 31 feet 2 inches if you want to get technical. All right. Let's look at this gem of a problem right here. Which one of these two is correct, A or B? Is the answer 18 or is the answer 12?
I think it's B.
Why?
Because it wouldn't be 4x is equal to 72, be 4x is equal to 78 or 64.
Right. So they multiplied wrong 8 times, but they set it up wrong too. What about if I change it to this? Now which one's right? Because I think that 8 was a typo.
Oh, so that's supposed to be a 9.
Yeah.
So is both of them wrong?
Why?
Is that what you're saying?
I'm saying which one's right. One of them is right.
I thought we just decided B was.
You think B's right?
Wait,
What about if I change that 8 to a 9? Is A not right now?
wait, let me think about it.
Well, 8 times 9, 72.
No, it's not.
So now, arithmetic-wise, they're both the same. Which one is the correct setup? B is the correct setup because I compare this line right here with this line right here, and then I compare the 4 to the 6 because the 4 and the 6 are ones that don't have archy marks on them. Here, it compared the 4 to the 9, which is wrong. But I think that was a typo. It would have been better if they hadn't done that, but they're so bad. So this is the correct answer because this is where the proportion is set up correctly. All right, there's your homework.